Hi, this video contains the questions from the topic Reaction Mechanism of Organic Chemistry, which were asked in the previous year's Neet exams from the year 2020 to 2024. You please listen. Now question number 1. Which of the following compound is most reactive in electrophilic aromatic substitution? Option number 1 chlorobenzene, option number 2 nitrobenzene, option number 3 benzene, and option number 4 phenol. In an electrophilic substitution reaction, the attacking species is an electrophile. An electrophile means an electron deficient species, and hence it will attack the reaction centers with more electron density. Example for electrophilic substitution reactions are substitution reactions of aromatic hydrocarbons or arenes. As the electron density of the aromatic ring increases, the rate of electrophilic substitution increases. Here in the given options, chlorobenzene and nitrobenzene are less reactive than benzene because chlorine and NO2 groups are ring deactivating groups. Therefore, these two benzene rings are electron deficient than benzene. But in the case of phenol, the benzene ring is much more electron sufficient than benzene because of the plus M effect of OH group. Therefore, here the answer is option number 4, that is phenol. Question number 2. Which of the following is a free radical substitution reaction? Option number 1 benzene with bromine in presence of AlCl3. Option number 2 acetylene with HBr. Option number 3 methane with Br2 in presence of light. Option number 4 propene with HBr in presence of benzoyl peroxide. In free radical substitution, the attacking species is a free radical. Free radicals are neutral species having an odd electron. Example for a free radical substitution reaction is halogenation of alkanes in presence of sunlight or UV light or at a temperature above 500 degrees centigrade. Therefore, here the answer is option number 3, that is bromination of methane in presence of light. Here the option number 1, that is bromination of benzene in presence of AlCl3 is an example for electrophilic substitution reaction. Option number 2, that is addition of acetylene with HBr is an electrophilic addition reaction. Option number 4, addition of propene with HBr in presence of an organic peroxide is an example for free radical addition reaction. Now question number 3. Which compound amongst the following is not an aromatic compound? Option number 1 cycloheptatriene. Option number 2 cycloheptatrienyl cation. Option number 3 cyclopentadienyl anion. Option number 4 cyclopropenyl cation. According to Huckel's rule, a cyclic conjugated planar system having 4n plus 2 pi electrons is aromatic in nature, where n is equal to 0, 1, 2, 3, etc. By substituting these values of n, we will get 2 pi electrons, 6 pi electrons, 10 pi electrons, 14 pi electrons, etc. That is, according to Huckel's rule, a cyclic conjugated planar system having 2 pi electrons or 6 pi electrons or 10 pi electrons or 14 pi electrons, etc. are aromatic in nature. This 4n plus 2 pi electrons means the electrons which are involved in delocalization. Then what is meant by a conjugate system? Structurally, a conjugate system means alternate double, single, double bonds, or double, single and lone pair, or alternate double, single and a negative charge, or alternate double, single and a positive charge. Here among the given options, option number 2, option number 3 and option number 4 are aromatic in nature because these are cyclic, conjugated and planar systems. In option number 2, it contains 6 pi electrons. In option number 3 also 6 pi electrons including the pair of electrons of negative charge, and option number 4 contains 2 pi electrons. The option number 1 is not aromatic because it is not a conjugate system. See, Here double, single, double, single, double, single, again single. That means there is no free orbital on this carbon. All its 4 valencies are already satisfied. Therefore, here the answer is option number 1. Now question number 4. Consider the following compounds or species. These are the compounds or species given. The number of compounds or species which obey Huckel's rule is dash. Option number 1, 6. Option number 2, 2. Option number 3, 5. And option number 4, 4. Listen, in this video we have already discussed about Huckel's rule in a previous question. According to this rule, a cyclic conjugated planar system having 4n plus 2 pi electrons is aromatic in nature, where n is equal to 0, 1, 2, 3, etc. That means a cyclic conjugated planar system having 2 pi electrons or 6 pi electrons or 10 pi electrons or 14 pi electrons is aromatic in nature. Now we can check how many of the compounds or species given are aromatic in nature. Here the first compound given is naphthalene. Naphthalene is a cyclic compound. It has conjugation because alternate double single bonds are there. This compound contains 5 pi bonds, that means 10 pi electrons. Therefore, this is aromatic because it contains 10 pi electrons as delocalized electrons. Here the second species is cyclopentadienyl anion. It is also cyclic, conjugation is there, that is double single lone pair or negative charge. It is also aromatic because it contains 6 pi electrons. The third species is cyclopropenyl anion. It is cyclic, conjugation is there, but it is not aromatic because it contains only 4 pi electrons. The fifth species is cyclopropenyl cation. Here also conjugation is there, cyclic. It is aromatic in nature because delocalized electrons is 2 pi electrons. The fifth one is cyclobutadiene. It is cyclic, conjugation is there, but it is not aromatic because it contains 4 pi electrons. The sixth one is cyclooctatetraene. It is cyclic, complete conjugation is there, but it is not aromatic because it contains 8 pi electrons. The last one, seventh one is anthracene. Anthracene is cyclic, conjugation is there. It contains 7 pi bonds, that means 14 pi electrons as delocalized electrons. Therefore, it is also aromatic. So here the number of aromatic compounds or species are 1, 2, 3 and 4. So here the answer is option number 4. Now question number 5. The compound that will undergo SN1 reaction with the fastest rate is. These are the 4 options given. We know in SN1 reactions, the reaction intermediate is carbonium ion or carbocation. As the stability of carbonium ion increases, rate of reaction increases. Stability of carbonium ion or carbocation decreases as benzyl carbonium ion greater than allyl carbonium ion, then tertiary carbonium ion, then secondary, then primary. Now we can compare the stability of the carbonium ions formed from the compounds given. Here in the first compound, after removing this bromine atom as Br minus ion, it will become this carbonium ion, which is a primary carbonium ion. In the second option, the carbonium ion formed from this compound is this one. It is a secondary carbonium ion. And the third option, that is bromobenzene, will become phenyl carbonium ion. Phenyl carbonium ion is less stable, that is even less stable than primary carbonium ion. And in the last option, the carbonium ion formed is a benzyl carbonium ion. It is more stable because this positive charge can be delocalized into the benzene ring, and hyperconjugation is also there because there are 3 alpha hydrogen atoms. So this is a compound which will undergo a SN1 reaction with the fastest rate. So here the answer is option number 4. Now question number 6. The most stable carbocation among the following is. These are the 4 options given. Listen, we have already discussed in the previous question that the stability of carbonium ion decreases as tertiary greater than secondary greater than primary. Here the first option is a secondary carbonium ion. Second option is also a secondary carbonium ion. Third option is primary. And fourth option is tertiary. Here the positive charge is on tertiary carbon. So here the most stable carbonium ion is option number 4.